Alrighty, my friends, as promised, here we are with page 451, moving on to describe reasonableness when it comes to division and word problems. Okay, let's start with number 1. Okay, notice the reading skills that we're going to be practicing as we are solving. What we need to do is activate thinking. What do I know? How can I connect this to what I already know? What is being asked to me, and how can I go back and check it? Okay, so keep that in your head as you're reading. A fish store has 8 empty tanks. After a delivery, 328 fish were divided equally among the tanks. How many fish were put in each tank? So what are some of the things that I could circle together that would help me understand what numbers are most prominent or most important in this word problem? Let's take a look. Could it be 8 tanks? So let me connect them. Those two go together. And if you guessed 328 fish, you were totally and absolutely correct. So we can't get any clearer than this, guys. It says divided equally. So what do you think we need to do? You're right. We need to divide. And after we divide, we are going to show that our answer is reasonable by using an estimate of our answer. We can even use inverse operation to help us. Okay, I don't think I have enough room in here, not because this is not enough room, but because I need more space to write. My letters are kind of big for you to see. Okay, so let's practice. Here we go. I'm going to divide equally, like the problem says. I'm going to divide 328 by 8. Okay, so I realize that 3 is less than 8, therefore I can't start there, so I'm going to hug 3 and 2 together and start dividing at the tens place value. So I'm really calling this guy a 32, not a 3. So 8 times what gives me close or over or exactly on 32 without going over. Let me let you think. Is it 8 times 1? 8 times 2, 8 times 3. Oh, it's 8 times 4. Notice where I'm placing my 4. I'm continuing to practice those great skills of place value by lining up my numbers. Since I said I'm starting here at the tens place value, my quotient must also begin there. Okay, so now I multiply. 4 times 8 is 32. I subtract and get a 0, and I bring down my 8. 8 divided by 8 is 1. 1 times 8 is 8. And I subtract and get a 0 remainder. So if I were to draw a picture with this, I can literally draw 8 tanks and put 41 fish in it. Okay, but I'm being asked to use estimation to model how I know that this answer is reasonable. Well, can we estimate something that's close to this number? I can start by saying 8 times 4 equals 32. 8 times 40 equals 320. 328 is about 320. So I'm using estimation to be able to come up with that answer. So I'm going to write right here 41 fish in each tank. 320 divided by 8 is 40. Which is close to 41. Perfect. How can I use mental math to divide 328 by 8? Well, I can use several strategies, but I'm going to jump into breaking apart. Why? Because visually in mental math, this is the fastest for me. I'm going to take 328 and divide 320, which is a fact family, and say I'm going to divide that by 8 first. I'm going to use the distributive property, and I'm going to divide the 8 that goes here in the 8th place value. You see it in the 1's place value. I'm going to say 8 divided by 8. So I broke this into two numbers. I broke 328 into 320 plus 8. Do you see that? Okay, so now 320 divided by 8 is 40. And 8 divided by 8 is 1. Voila, 41. There it is. Okay, moving on to number 3. A local sports club has 108 fourth graders sign up to play soccer. There are 9 teams, and each team will have the same number of players. How many players will be on each team? Estimate to show that your answer is reasonable. Well, I know that 9 times 10 is 90. So I'm going to jump into fact families. 9 times 11 is 99. And 9 times 12 is 108. So this is the fact that I'm looking for. Okay, so how will I estimate? I will use compatible numbers. So I'm going to say use compatible numbers. What does that look like? I can say 108 can be rounded to 100 divided by, I'm going to change the 9 to a 10. So 100 divided by 10, it's about wiggly 9, about 10. 10 is close to 12. Perfect. All right, number 4 through 6. About how much money does it cost to feed an 11-year-old child for 1 week? I guess this shows that we need to take a look at that chart. Okay, so if we look at the chart, it reveals the age of a child versus the average monthly cost to feed a child. Okay, so what could we do to figure that answer out? How much money does it cost to feed an 11-year-old child for a week? Well, I find the 11-year-olds are here, and I look at the amount of money. And this is telling me that this is monthly. So what could I divide by? Would I divide by 7 because it says a week? Or would I divide by 4 because there are about 4 weeks in a month? Let's try it. Let's say that we're going to divide by 4 because there are 4 weeks in a month. So 196 divided by 4. Where to start dividing? At the tens place value. So 4 times the number gives me close to 19. I want to say it's 4. 4 times 4 is 16. Subtract and get a 3. Bring down the 6. And 36 divided by 4 is 9. 9 times 4 is 36. Subtract and we get a 0. So the actual answer is 49. What can I say as my estimation? Couldn't I round this to 50? Yeah. So we could say, since this is about, I'm going to answer with an about as well. About $50. Okay? All right, let's take a look at the next part. A family spends about $300 to feed their child for 8 weeks. How old is the child likely to be? So which one of these could be used to estimate $300 total for 8 weeks? If we know that one of these is 4 weeks, that means that each one of these numbers would have to be double. What does that mean? That means that 1 month, which is also 4 weeks, is whatever they give us here. So 2 months, which will be 8 weeks, will have to be whatever they give us times 2. Do you see that? So if I times this one times 2, about, I'm going to say the answer comes out to 200. This one will come out to 250. This one will come out to 320. Too big. Look at this one. 200. So if I double that, that will be 400. Let's try the next to biggest one. 168. I could probably round that to 150 because it's a little bit closer, right? It's a friendly number. And of course, 150 times 2 is about 300. About $300. So the only one that would work then is the category for this age. So my answer will be the age, right? How old? They want to know how old is the kids. So 6 to 8 years old. Because I found my answer right there. Next one says, is your answer for exercise 5 reasonable? Did you answer the right question and how do you know? Well, I'm going to say yes, it is reasonable because 8 weeks is about 2 months, and 300 divided by 2 is about 150 per month. The closest cost to 150 is the children age 6 to 8 years old. Okay. Alrighty. The back of this page you will do to practice on your own, but I'd like to take a look at the homework page with you. Okay. Alright, so let's take a look at that page. That page should be 454. Put it in front of you. Notice that in this page we only have a couple of problems. We have 1, 2, 3, 4, 5, 6 little problems. Okay, so not a whole bunch, but what is that going to require? It's going to require that we really pay attention to our reading skills, and if we struggle in reading, we're going to struggle here. So be aware of your weakness. Okay, if you're aware of your weakness, then you can do something about it. Here we go. First of all, we take a look at this problem and we notice that there's a chart there. So my recommendation has always been that you take a look at the chart and kind of try to understand what it is that they're showing you. Here it says triplex theater. There are some show times and there's some people that attend those show times. And I noticed just by looking at the numbers that most people attend at 5:30 p.m. Well, what do you think that's happening? Why do most of the people go at 5:30? If you're saying or thinking that it's because people who work don't get off until later, then you're probably right. Most of these audiences here are probably working people. So let's take a look at what they're giving us and what the prompt is and what it is that I have to answer. The total attendance figures for one day. So this is one day. I'm going to write in here one day, which is a lot of people, right? One day and the triplex movie theater are shown in the table. A movie is shown on each of the theater's 3 screens at each showtime. If the same number of people saw each movie show at 1, how many people saw each movie at 1? Estimate to check that your answer is reasonable. Okay, so let's take a look at that. What would I do to be able to estimate this? Well, I'm going to first of all decide which one of these do I look at. Did they tell me? Yeah, if the same number of people saw each movie shown at 1. So I'm only going to look at the 1 o'clock show. I'm going to go ahead and ignore the other 2 for right now because I don't think that I need to know anything about that. Not yet. It might be for this one. Okay, so here we go. How can I find that out? Well, I would have to take 459 and divide that by how many movies or screens are showing the movie. How many screens are showing the movie? 3. So notice 3, and here's my other number. So I'm going to take my scratch paper and divide 459 divided by 3. 4 divided by 3 is 1. 3 times 1 is 3. Subtract, bring down the 5. 15 divided by 3 is 5. 3 times 5 is 15. Subtract, bring down the 9. 9 divided by 3 is 3. 3 times 3 is 9. Subtract, no remainder. So, how many people saw each movie? 153 people. Let's estimate. Okay, so let's write that first of all. 153 people. How can we estimate that? Well, we can change, instead of saying 459, we can say 450 divided by 3. I know that 45 divided by 3 is 15, so all I have to do is add a 0 to my answer there, which is close to 153. It is big R, reasonable, right? Excellent. Now we can take a look at the second half of this. Could the audiences for the movies at 3:15 have the same number of people in each of them? 3:15. So I'm going to erase my scratches that I made to 3:15 so I can really think about this one. Could the audiences have the same number of people in each of them? Could the audiences for the movies at 5:30 have the same number of people in each of them? And our job is to explain. So not only do we get to answer the question, but we have to explain it. So let's take a second look at this. Okay, it looks like I'm going to have to take each one of these movies and divide it by, remember, still the same, 3 screens. So I'm going to take this information and divide it by 3 to tell me if the movies at both of those different show times had the same number of people. So I'm going to take my space right here and divide it into 2 sections. And I want to write small. Okay, so we're going to go for the 3:15 movie, which is 347 people, and we're going to divide that by 3. So 347 divided by 3. 3 divided by 3 is 1. 3, subtract, bring down the 4. 4 divided by 3 is 1. 3 times 1 is 3. 1, bring down the 7. I got a 17. 17 divided by 3 is 5. 3 times 5 is 15. Subtract, I get a 2. So remainder of 2. So my answer is 115 remainder of 2 for the first one. Let me try the second one. It says that the last one had 562 people. Wow, that's a lot of people. So let's do 562. I'll try to write tiny. Divided by 3. 5 divided by 3 is 1. 1 times 3 is 3. Subtract, get a 2. Bring down the 6. 26 divided by 3 gives me an 8. 8 times 3 is 24. Subtract and get a 2. Bring down the other 2, and now I have a 22. 22 divided by 3 is 7. 7 times 3 is 21 with a remainder of 1. So my answer here is going to be 187 remainder of 1. Well, first of all, I noticed that both of these guys have a remainder. So what does that remainder mean? It actually means that there were 2 people in this group that couldn't go see the movie, and there was 1 in this group that couldn't go see the movie because they were not equally divided. So, do they have the same number of people? No, because 347 divided by 3 is 115 remainder of 2, and 562 divided by 3 equals 187 remainder of 1. The remainders show that not an equal number of people could see the movie. It couldn't be divided equally. So basically they're asking us, is that even possible? And the answer is no, because the numbers to begin with are different. Okay? All right, moving on to 7. Sebastian ran around the track this many times. He ran a total of that many meters. Question is, how many meters is 1 lap? So when I find my secret answer, my mystery answer, my answer is going to mean meters. Okay, so how many meters is 1 lap around the track? Estimate to show that your answer is reasonable. So I'm going to take 1,624 and divide it by 4. Hug that together. 16 divided by 4 is 4. 4 times 4 is 16. Subtract. I bring down the 2, but I can't divide that, so I'm going to have to put a place value holder there. 0 times 4 is 0. Subtract, and I get a 2 still, but I'm going to now be able to bring my 4 down. 24 divided by 4 is 6. 6 times 4 is 24 with a 0 remainder. So, how many meters? 406 meters. That's one way, and the estimation will be to change this number to 1,600 divided by 4, which is going to equal something like 400 meters, which we were pretty close. Okay, let's take a look at number 8. At the orange grove, the Wilson family picked 258 oranges. They filled 6 boxes and part of the 7th box. If all of the boxes are the same size, which statement is true? I think I'm going to need a picture for this one, so get your piece of paper and let's draw it together. 258 oranges divided into 6 boxes. So I'm going to draw 6 boxes. 1, 2, 3, 4, 5, 6. And it says in here a part of a 7th box. So I'm going to take this one and put it diagonal. Box 1, box 2, box 3, box 4. Oh, I have doubled up the 2. Sorry about that. This is going to be a 3. This is going to be a 4. This one will be a 5. Box 6 and box 7. Excellent. Now let's pay attention to what they're asking us to do. If all of the boxes are the same size, which statement is true? So I'm going to use the answers to help me find the correct answer. Each box can hold up to 30 oranges, but not more. So 258 divided by, it says that it filled all of the 6 boxes and part of this, so this must be the remainder. So let's see, divide by 6. Why did I stop to do that? I stopped to do that because it prompted me to find out what my division sign will be if I divided that equally. Did you see what happened? If I divide this by 6 boxes, which it tells me that it fills 6 boxes, then I really don't have remainder, so this box is empty. So it can't be that one. Okay, let's take a look at the second one. Each box can hold up to 35 oranges. Well, if I divide by 6, my answer should be 43, and it says in here that it can hold up to. That means the limit is 35. Well, the 43 answer here proves that it's not, so that can't be it. Okay, now let's look at C. Each box can hold up to 40 oranges, or each box can hold up to 45 oranges. Which one is closer to 43? Remember that it says that some of these boxes, some of these oranges were here in this partial. Okay, so it could mean then that in each one of these I had an equal number, and I have to make sure that this is a remainder. Okay, so let's see what happens when I predict that this is a 40. Okay, which is what this one says. Let me do C. 40 oranges. So 6 times 40 equals 240, and I started out with 258. So part of these are sitting here. So in this little box there are 18. Okay, look at this one. Each one can hold up to 45 oranges. What does that mean? It means that all of these can be filled, but most of these, this one is almost full. And the statement says part of a 7 box. So this one can't be it, because that means that the box is almost full. So the only one that qualifies, even though it's not 100% right on the money, is this one, because it gets close to the definition of how much the partial box is filled. Okay, all right, let's take a look at number 9. A company packages every basketball in a cardboard cube, and I've seen those at Academy. The cardboard cubes are packed equally into 8 large boxes for shipping to different stores. If the company packs this many basketballs in one day, how many basketballs in cardboard cubes are in each large box? Let's think about this. What do you think you need to do in order to find this answer? Well, it shows a whole number and it shows individual boxes. Let me see how many. It says in here 8. Let's see if this is 8. 1, 2, 3, 4, 5, 6, 7, 8. So are they multiplying this times 8, or are they dividing? I think they're dividing. So let me see. Let me try right here. 432 divided by 8. I'm going to hug that 43, right? Because 4 is too small to be divided by 8. And I'm going to say 8 times 5 is 40. Subtract and get a 3. Bring down that 2. And my new dividend now is 32. And I say 32 divided by 8 is 4. 4 times 8 is 32. Subtract and get a 0. So how many are in each large box? 54 basketballs. How do we know? Because we can change this number to 400 divided by 8 equals 50. And 50 is close to 54. Okay? Ooh, this one is super long. Let's see what this one has to say for us. It says, there were this many people in the audience at opening night of the school play. That many people on the second, and that many people on the third night. So the audience is like not so high here and super high here. Okay? The next 3 shows had the same total number of people attend as the first 3 shows. There were the same number of people in the audience for each of the last 3 shows. How many people saw this 6th performance? In other words, this forms a pattern. So show 1, show 2, and show 3. So let's see. Show 1 was 975. Show 2 was 1,263. And show number 3 was 1,035. Okay? So if I wanted to find out how many on the 6th, what would I have to do? Well, first, I would have to make sure that all of these were added together. I'm going to put a plus sign in between so that I can come up with a better number that I can distribute equally, because that's what they told me. It says in here, had the same total number of people attend as the first 3. So I'm going to take that plus that plus that. Okay? So 975 plus 1,263 plus 1,035. Let's see what that totals up to. Perfect. It equals to 3,273. Now I can take that and distribute them equally into the 3 plays or the 3 shows. So let me go ahead and divide that. 3,273 divided by 3 gives me a 1 and a 3 here. Subtract, bring down the 2. Cannot do that. 0, but I still have to multiply by it. 0 times 3 is 0. Subtract and get a 2. Bring down the 7. So now I have a 27. Okay? 27 divided by 3 is 9. 9 times 3 is 27. Subtract. Bring down that last 3. 3 divided by 3 is 1. 1 times 3 is 3. And when I subtract, I have a 0 remainder. So in each show, if I were to put all those people together and then redistribute them equally, I would come up with that many people per show. So I'm going to say 1,091 per show. And how do I know? Because 3,000 divided by 3, which is what I could round that number to, equals 1,000. So it is a good estimate. All right, my friends, I have helped you with the back of the homework page. I'm expecting you to finish the front of this page as well. So now you are looking at 2 whole pages. Okay, let me give you the other 2 pages that you will need to work on your own. Okay, get a piece of paper down so you can write them down. And here we go, my friends. This is the last. On page 455 and 456, which is the end of the topic, you're going to only do number 3 and 5 on page 455. In page 456, you will only do number 4. Then you will also tear out this one single page, 459, 460, which is the topic A test, and you will finish that. It's only 12 questions and it's due today. Not a whole lot of work because you already know how to do the division problems, okay? So I hope you have a great day. This part right here, I'm going to put in here, not due November 27th. So you have plenty of time to finish if you're unable to finish today. I hope you have a great Thanksgiving holiday, and I'll see you around. Bye.